Okay, I rushed through this again. Let me just go ahead and finish that problem up. So if I was to look at this problem and say, you know what, this is vector W, this is vector V, do we see that if I follow this trend altogether, do you see that this is one vector, this is another vector? The resultant is simply V plus W from what we did graphically. Well, algebraically, I know how to find V. Look at V. V, if this is 30 degrees, then this is 60 degrees. With reference to the x-axis, I'm moving 60 degrees down and an r of 600. How do you find the x and the y, or the I and the j component? Wouldn't that be 600, the cosine of, either you do 60 degrees but recognize you are in this quadrant, or you say, you know what, if I want to do this right, that's 300 degrees. And 600, the sine of 300 degrees, that would be 600, the reference angle of 60 degrees, that's 1/2 positive in that quadrant, radical 3/2 negative in that quadrant. So I could say vector V is actually move 300 to the right, negative 300 radical 3 down. You will be at that position. If I look at vector W, I'm looking at you rotating 45 degrees down. Well, either you say that's 45 degrees, but recognize you're in this quadrant, or you say this is 225 degrees. 315 degrees. So, if I know this magnitude is 40, wouldn't this be r times the cosine of theta, 40 times the cosine of 315 degrees, and 40 times the sine of 315 degrees? Again, you could do 45 and 45, just say x is positive, y is negative. This will be 40 times radical 2/2. In this quadrant, cosine is positive and negative. So you could use whatever you want. And wouldn't you say vector W is actually 20 radical 2 and negative 20 radical 2? By the way, I did finish this problem in the previous section, but then they wouldn't let me upload it in, They wouldn't let me upload it in YouTube. So, if I look at the resultant force, isn't the resultant vector V1 V plus W? How do you add vectors? Don't you add the I component and the j component? And there it is. When they say, find us the ground speed, that's the magnitude of r. Remember, I said magnitude behaves like a constant equivalent, but it consists of, has units. So, a bit messy, but a calculator could do the job. That one. And if I throw this in my calculator, I'll get 639. And what is that going to be? Kilometers per hour? The same units? Kilometers per hour. And what happens now if I want to figure out the direction? If I take tan of theta to equal the negative 300 radical 3 minus 20 radical 3 over, and this is going to always happen when you are dealing with vectors or tangent. If I plug this in my calculator, the calculator will give me negative 59 degrees. In this case, it's okay. The calculator is giving me this angle. How would you say that? Wouldn't you say start on the east and 159 degrees toward the south? So start on the east, there's the east, and rotate 59 degrees toward the south. And there it is. Right? So if I'm in the right quadrant, it's okay. But if I was in this quadrant, then I have to add 180 to that angle like I did on the previous problem. Here, when I plug things in my calculator, this value is negative. Anytime I use a calculator, the calculator using tangent is going to think you're in this quadrant, but in reality you're in this quadrant. So all what you do, add 180 to that, and that will work. So that concludes this section. I want to give you the homework. There's your homework, and that concludes this section.